Well, here they say we need to consider this linear pattern. And the word consider means you look at what you are given and you make sense out of it. So the linear pattern is 5, 7, 9, and this goes on all the way to infinity. Now, the first question says we need to determine term number 51, and this is for 3 marks. And you really can't determine term number 51 unless you know the general term. So we need to find the general term first. Well, let's go ahead and do that. Well, since we have done an arithmetic sequence, yes, we know that a linear pattern is an arithmetic sequence. We know that we don't really need the general term itself. Well, what is the pattern? We have 5, 7, 9. And of course, this goes on to infinity. Well, here we can see that our A is simply 5, and our constant difference will be term number 2 minus term number 1, which is simply a solid 2. So then our nth term is given by A plus n minus 1, and then we say times D. And now they're asking us to find term number 51. Well, it's very easy to find it. We can just say the first term is 5. How many terms there are? Well, it's 51 minus 1. Not really how many terms, but what is the position of the term? And D is the constant difference. You didn't need to find the general term first, but you had to know what is A and what is your D, and you can easily find term number 51. So, well, if we substitute this into the calculator, we find that term number 51 will simply be 105. And next, they say we need to calculate the sum of the first 51 terms. Okay? So, well, we know that the sum of the first number of terms is given by the number of terms divided by 2 times twice as much the first term, and which is added to n minus 1 times the constant difference. But we are looking for a sum of 51 terms, so we simply say 51 divided by 2. And A is the first term, which is 5. The number of terms, that is 51. And our constant difference is a solid 2. Then it's very, very easy to find the sum. Or you could have used the other formula as well, because you now know the value of term number 51, which is the last term of your series or other sequence. You could have just said the sum of 51 terms will be 51 divided by 2. Then you times this by the first term plus the last term. Yes. And in both of those cases, when you substitute everything into your calculator, you simply get 2,805. That is the sum of those 51 terms. Well, next they say we need to write down the expansion of this series. So we have the sum of this series that is represented by the general term, 2n plus 3. But it's the sum from n equals 1 to n equals 5,000. But then in our expansion, we only need to show the first three terms and the last term of the expansion. Okay? Well, how do we get the first term? By substituting n equals 1. And when you plug in your n equals 1, you get a 5. When you plug in n equals 2, you get a 7. N equals 3, we get 9. So this means when we expand this, we are simply going to get 5 plus 7 plus 9, plus many terms in between up until the last term, which we obtain by substituting n equals 5,000. So when you say 5,000 by 2, and then you say plus 3, you simply get 10,003. So that's the expansion. Then the next one says, hence or otherwise, calculate the sum of those two sums. And of course, show all workings. Now, one thing we know about the phrase hence is the fact that we need to use what we found previously in order to do this question. That's the meaning of hence. But when they say otherwise, you can choose not to use what you found previously. You can choose to do something that is brand new. So let's try to use hence and see where it gets us, right? Now, this is what we know. We know that the sum from n equals 1 to n equals 5,000 of 2n plus 3 is actually 5 plus 7 plus 9, which goes on all the way to the last term. But now, since we want to add those two series, we want to expand both of them. I think it makes perfect sense for us to show the last three terms on this series as well, to see our things clearly. Then we can say, okay, fine. How do we get our last three terms? We know that the last term we substitute 5,000. But then for the term before the last, we substitute 4,999. And then we say plus 3. So we get 10,001. Then we substitute 8 there. And we get, oh, actually, here we are supposed to have 9999. And then here we have 11, and then we say 1. And lastly, we have 11, and then we say 3. Yes, that's what we are supposed to have. Then we come back and we want to expand the second series as well. And this is from n equals 1 to n equals 4999. But the series is represented by the general term negative 2n minus 1. And we need to show all the workings. So let's show them that for this one. In order to get the first term, we had to substitute that. And by the way, for the previous one, you really didn't need to show these ones. There was absolutely no need. But then we are just showing them because it makes our lives easier, but there was no need to show those. You'll see how it will make your life easy. Then we say, okay, fine. We have -2, in fact, 2 there. And then we still have -2 into 3. And we can add many terms in between up until the last term, which we obtain by substituting n equals 499. Right. Well then, when we plug everything into our calculator, -2 into 1 minus 1, well, we get -3 plus. If you plug in your 2 there, -5. You plug in your 3, -7. And you add many terms in between. Once again, let's find the last 3 terms. The last term, we know that we obtain it by substituting 499, which means the one before the last. We substitute an 8, the one before that, a 7. So we have 4997, and we get -999, and then we say 5. Then we substitute an 8 there. And when we substitute an 8, we simply get what? We simply get -9997. And when we substitute our 9 there, well, we simply get -9999. That is our last term. Well, this one actually doesn't work best if we have those, but it does work best. This one I'm referring to. Let's go to this series once again and substitute the 4th last term. In other words, which we obtain by substituting 499 what? 6. No, 7 actually, because this one was 5,4999. Yes, 4,998. So it means in order to get the 4th last term, let's substitute 4,997. I just want you to see something, that's all, that will make life to become easy. Or rather, so that you can agree with me. Yes, that's what I wanted to say. When you substitute 4,997, you find that the 4th last term is actually +997. So what? Well, now we can come back and say, if I must add these terms now, because that's what the question is asking for. It is asking us to add these terms together. I want you to realize something. Well, what is it I want you to realize? I want you to see that in this sequence, 7 is positive, but in the other sequence, 7 is negative. So if you add those up, you get a 0. In this sequence, 5 is positive, but here it is negative. If you add them up, you get 0. 9 is positive here, it's the 3rd term. It's going to be negative here, it is the 4th term. Do you see that? Okay, fine. We keep on going further. The last term here is negative 9999, but here we have it as positive. So if you add them up, well, you simply get a 0. If you take this one, the second last, it's negative. If you add it to this fourth last, you're going to get a 0. So those middle terms are exactly the same. That's why they cancel out. So what you're going to show them is what? Well, we have negative 3 that will survive because we don't have a corresponding 3 in that other pattern. But you show them that those middle terms will all add up to 0, those that are exactly the same. But which terms will survive? Well, the 1001 will survive, as well as the 1003. They will survive. And if you now add those terms together, well, you have negative 3 plus 1001, 1003. Well, actually, it's 10,000, not 1,000. Nevertheless, we simply get 2,000, in fact, 20,000, and 1. Yes, that is what we get. All those middle terms will give us zeros. Then the survivors will be negative 3, 10,001, as well as 10,003. Right. But then how would you use the otherwise part of this question? Well, the otherwise is quite simply, you could have just used the formulae instead of writing this. How? You could have went to this series and said, well, for the sum from n equals 1 to n equals 5,000 of this general term, 2n plus 3, you could have just said, well, this sum, I'm going to evaluate it aside. And then I say, well, the number of terms is 5,000 divided by 2. And then you multiply this with what? With 2 times a. Well, a is 5. And then you have 5,000 minus 1, which is 4,999. And you times this by the constant difference, which is 3. You could have found this sum and then come back again and find the sum for the other one. All right? Using the very same formula. And then add those two sums together. Then you are still going to get 20,001. That's the otherwise, doing something that is brand new.